fractions. We have a fraction here, we have a big denominator here, we have a huge fraction here. What you want to do in this situation is figure out what the LCD is. Figure out what the LCD is for this stuff, meaning these two, and figure out what the LCD is for these two. Okay. If we factored this, it would be x minus 1 times x plus 1. Okay. Always factor if you can when you're trying to find the least common denominator. And so between these two, we'd have a least common denominator of x plus 1. And between these two, we would have this x minus 1 and x plus 1 as our LCD. Okay? So we're going to treat the numerator of the big fraction separate from the denominator of the big fraction and convert to least common denominator and convert to least common denominator. Okay? What we're trying to get is just one fraction over one fraction so that we can multiply by the reciprocal. Alright. So, what we're doing is just converting. We have 1 over 1, and if we were converting that to a least common denominator where the denominator is x plus 1, what would we, Lizzie, what would we convert this to?
X plus 1 over x.
Very good. So x plus 1 over x plus 1 and minus 1 over x plus 1. So we've converted. Now we can combine, and in the numerator we would just have x plus 1 minus 1 or x. And in the denominator, this 1 over 1 becomes, I'm going to write it as x squared minus 1 because it's a little simpler. We have x squared minus 1 over x squared minus 1 and plus 1 over x squared minus 1. So we're going to combine the two fractions, and that will give us a complex fraction. So working back, we then have x plus 1 minus 1 for x. And in the denominator, x squared minus 1 plus 1. So the minus 1 and plus 1 cancel out, and we get x squared over, and we'll write it as x squared minus 1. Okay. So we figured out least common denominator for up top, the numerator, and for the denominator, and we are in a position now where we can simply multiply by the reciprocal. So x over x plus 1 times, and this I'll now write as, or in its factored form. So we are ready to cancel. Okay, factoring and canceling is what we do with these rationals. We might write this that way. X and x squared reduced to 1 and x. And we have an x plus 1 that will cancel with an x plus 1, leaving us with just x minus 1 over x. Okay, so notice for the final answer, it's not x equals a number. We weren't solving an equation, we were simplifying an expression. Along with this, we have to talk about the domain restrictions. So we would say, for domain restrictions, there are values of x that are not allowed. So anytime you make the denominator 0, anytime a value of x would make the denominator 0, we say that's not allowed. So Jonathan?
So 1 and negative 1. Or just negative 1, because...
Alright, negative 1 from here.
Yeah.
This, in factor form, is x plus 1 times x minus 1. So we have a couple values. We have x cannot equal negative 1. X may not equal positive 1. And in addition, we have an x down here which would make 0 an unallowed value as well. Okay. Looking at the original question, anytime when you're looking for domain restrictions, look at the original question. look at any fraction you have when you're solving through and look at the final answer. It's not just, if you just looked at the simplified final answer, it would just be x cannot equal 0. You want to look at the original, you want to look at anywhere you had a fraction in solving or simplifying through. Questions? Alright, and notice how I described the domain restrictions. X may not equal. You could also phrase that as all real numbers except x equals -1, x equals 1, or x equals 0. Okay. So,